Hey, welcome back. In our last explainer, we really dove into asynchronous JavaScript and how it handles time. So now we're going to build on that foundation. We'll explore how JavaScript actually connects to the outside world, and maybe more importantly, how we can structure our code to build some seriously powerful, scalable applications. Let's get right into it.
So think about it. How does our code talk to servers? How do we structure it so it doesn't just become this tangled mess of spaghetti code? Well, that's exactly what we're tackling today. This is the architectural toolkit of modern JavaScript.
We're about to make a pretty crucial shift in how we think about our code.
Yeah, this isn't just about syntax anymore. We're zooming out to see the bigger picture. We're going from being a coder, focused on one little component, to being an architect, someone who designs projects that are maintainable, scalable, and really, really efficient. Okay, first things first. Pretty much every modern app needs to connect to data, right? And the way it gets that information from the outside world is through APIs.
The Fetch API. This is your gateway to the internet. Just think of it as JavaScript's built-in tool for making network requests. Anytime your app needs to load information from a server, doesn't matter if it's user data, a list of products, or, funny cat picture, Fetch is going to be the tool for the job. Before Fetch came along, we had this thing called XHTML, or XHR, and as you can kind of see from the tangled mess on the left, it was complicated. It took a lot of manual setup. Fetch, on the other hand, is that smooth, clean path on the right. It's built on promises, which makes handling asynchronous requests so much more intuitive.
And here's that promise-based pattern in action. First, you fetch a URL. That returns a promise. Then, the first then block gets the initial response from the server. But, and this is a key point, that's not the data itself, it's just the headers and status. We still have to call a method like .json to pull out the body. And guess what? That also returns a promise. So the second then block is where you finally get your hands on the actual data. And of course, .catch is there to grab any network errors that pop up.
Now let's look at a much cleaner way to do this. Async await is basically just some nice syntactic sugar on top of promises. It lets our asynchronous code look and feel a lot more like regular, synchronous code. You just await the fetch call, then you await the response conversion. It's the same thing happening under the hood, but it's way more readable and so much easier to debug, especially when you wrap it in a try-catch block. Honestly, this is the standard for modern JavaScript.
Of course, in a real-world application, things get a bit more complex. You have to handle HTTP errors like a 404 not found because Fetch doesn't automatically see those as network errors. You might also want to use something called an abort controller. Why? Well, imagine a user starts a huge download, then immediately clicks away. An abort controller lets you cancel that request, which saves their bandwidth. The big takeaway here is that Fetch is super powerful, but using it professionally means you need robust error handling. Okay, so you've fetched your data. Now what do you do with it? You need a structured way to manage it, and the logic that works on it. And this is where classes come into play.
A class is really just a blueprint. It's like a cookie cutter. You define the properties and the methods an object should have, and then you can stamp out multiple instances of that object. Each one has its own data, but they all share the same structure. It's really just a cleaner syntax for something JavaScript has always done with prototypes, but it gives us this predictable, reusable structure that's just way easier for teams to understand and maintain. And this slide right here perfectly illustrates the idea. We've got a base user class with a name and a greet method. Then we can create an admin class that extends the user. This new class inherits everything from the user class, but it can also have its own unique properties, like a permission level. That's the power of inheritance and code reuse right there.
So let's break down the anatomy. The constructor is the setup method. It runs just once when you create a new object. Methods are the functions that define what the object can do. The extends keyword is how we create a child class that inherits from a parent. And super is absolutely crucial. It calls the parent class's constructor, making sure the parent is all set up before the child starts adding its own stuff. Without it, you get an incomplete object, and trust me, you'll get bugs.
So we've fetched our data with APIs, and we've organized our logic with classes. But what if that data is a huge list, or maybe it's a continuous stream? We need an efficient way to process it, piece by piece.
An iterator is one of those fundamental concepts in JavaScript. It's an object that knows how to get items from a collection one at a time. and it keeps track of where it is in the process. Fun fact, anytime you use a for-of loop on an array or a string, you're actually using an iterator under the hood without even realizing it. This slide shows you what's really going on behind the scenes. You can get to an object's default iterator using symbol iterator. When you call its .next method, you get back this little object with two properties, the value of the next item and a Boolean called done that tells you if you've hit the end of the line. This super simple pattern is the heart of all iteration in JavaScript.
Now, generators take this whole idea and kick it up a notch. They're special functions, you can spot them by the little asterisk, that can be exited and then re-entered later. All of their context, all their variables are saved across those reentrances. The magic word here is yield, which pauses the function and sends a value back to whoever called it. They are incredibly powerful for managing complex, asynchronous flows.
And this demonstrates their power perfectly. See, this generator function doesn't calculate all the numbers at once. It produces one number, pauses with yield, and just waits. Think about an infinite scroll feed on a social media app. It doesn't load a million posts at once, right? It loads them as you scroll. Generators give us a super clean way to build that exact kind of memory-efficient, lazy evaluation.
Okay, we've got our data, we have our logic, and we have efficient processing. The final piece of this puzzle is organization. How do we keep our entire application from becoming one giant, unmanageable file? Modules are the absolute foundation of any serious JavaScript project. They let you split your code into separate, self-contained files. You can export functions or classes from one file and then import them into another. This keeps your code clean, it stops variable names from clashing in the global scope, and it makes everything so much more reusable. For a long time, JavaScript had a few different module systems. Node.js used CommonJS with its require and module.export syntax. But the modern standard, the one supported natively in browsers, is ES modules. That uses the import and export keywords you see today. ES modules are also static, which means their structure gets analyzed before the code even runs, and that allows for some really powerful optimizations. With ES modules, you basically have two main types of exports. Named exports are like a toolbox. They let you export a bunch of different items from a file, and then you import them using their specific names. A default export is more like a single pre-packaged item. It's for the one main thing a module provides, and you can import it with any name you want. A good rule of thumb is to use named exports for utility libraries and default exports for a module's main feature.
Okay, let's bring it all home. Let's see how these four concepts come together to form the complete toolkit for building modern, professional JavaScript applications.
It's really a complete workflow when you think about it. APIs, like fetch, go out and retrieve the data. Classes give you the blueprints to manage that data's logic and its state. Iterators and generators give you an efficient way to process all that data, especially if it's a huge stream. And finally, modules provide the organizational backbone that keeps your entire code base clean, scalable, and professional.
So now you have the architectural tools, but how do you make sure your application runs fast and doesn't crash? Well, in our final explainer of this series, we're going under the hood to look at memory management, garbage collection, and the tools you need to debug performance issues like an absolute pro. I'll see you there.